Hello everyone, a warm greetings to all of you. I hope all of you are doing great in this pandemic situation. We are here to propose a project presentation for Avishkara 2020. Our project title is Smart Garbage Boot G-Boot, which is a smart garbage collection robotic vehicle using artificial intelligence and machine learning, which is an Swachh Bharat initiative. Our team members are myself, Navin Nagendra Pachangi, Akshay B. Chaugle, Navin Narayan Pachangi, and Asim R. Mumin. Our project is selected under general category and our project ID is PROJ underscore GEN underscore 1. So let me start with the contents. In this slide, we can see the contents of our whole presentation. The further slides will be explained by my friend Asim Momin.
Thank you, Navin. Now let us see the abstract. This project presents a smart garbage collection robotic vehicle which operates in the desired area of interest. The robot is able to detect the garbage accurately and autonomously by using a deep neural network for garbage recognition. In addition, with the ground segmentation using a deep neural network using RFID kit, a technique is proposed to guide the robot to move around. Swachh Bharat Abhiyan was launched by the Prime Minister Narendra Modi on 2nd October 2014. This project proposes the concept of smart garbage collection robotic vehicle for autonomous garbage collection using artificial intelligence and machine learning. Now see the objectives. First one, development of robotic vehicle. To develop an autonomous robotic vehicle can collect the garbage littered in public places. Second one, implementation of artificial intelligence and computer vision. To implement artificial intelligence and computer vision to detect and classify the type of garbage. Third one, development of neural network. To develop an neural network to detect different type of garbage. Fourth one, robotic arm development. To develop an robotic arm incorporated on the top of the vehicle which can automatically pick the garbage detected littered on the road. Fifth one, development of an onboard system. To develop an onboard bin system where the robotic vehicle collects the waste littered on the road. This is our prototype of proposed robotic vehicle system. First one is side view, second one is top view. Next to that one is front view. Now see the overview of the proposed robot, in which we have methodology, hardware and software use, results and discussion, future scope. Methodology is nothing but step-by-step process which we'll discuss in further slides. Then we will see some hardware and software that we are used in our project. After that we will discuss some experimental results of our project outcome. We have some future scope of our project which will explain in this project presentation later. Further slides will continue by my friend Navin Pachangi.
Thank you, Asim. Now let us see the methodology, which have several steps starting from problem definition to optimization. Let me report one by one. First one is a problem definition. The increasing urbanization of India possesses so much threats. A huge ton of waste is generated in India, but only 5% of this large amount of waste is recycled. One possible solution for this problem could be identifying and classifying the waste at the starting stage itself. Currently, there is no effective system for segregation of various types of wastes. The purpose of our project is to make a simple, low cost, and user friendly segregation system to process the waste management more effectively in India. Then, as a second part, we have a hardware selection. The figure 2 shows the hardware configuration of Smart Gboot, where we have the motors and its controllers. The DC motor, along with the L298 driver, is mainly responsible for the movement of our robotic vehicle. Then we have a stepper motor along with A498 driver for the horizontal movement of arm purpose, and then we have a servo motor with a 16 channel servo driver, which is helpful to control the arm and dustbin. Then we have a robotic arm. The development of a robotic arm is explained in the further slides briefly. Then we have a garbage or container, which is a dustbin. Then we have a power supply, which is a 12 volt power supply along with the XL4015 controller. Then we have RFID kit sensor and buzzer. RFID is nothing but a radio frequency identifier sensor, which is mainly responsible for the navigation in our project. Then we have a camera and HDMI display as the input and output sensors, and we have a CPU. CPU, we have used a Raspberry Pi model as a CPU. The Raspberry Pi model is mainly responsible for all the activities in the robot. The tasks executed by this model are it will capture the garbage littered on the ground, and it will work on the ground segmentation, and also when the garbage is detected in the area of interest, then it will allow the robot to move forward to pick that garbage. Meanwhile, it will also work on the image classifier, and it control the all motors to redirect waste in such a way that the garbage should be fall into its respective bin. Then we have a hardware development. We can see the figure 4, where the development of hardware is started with the base of the robotic vehicle, which is developed by the help of steel rods in a proper design of 355 millimeter in length, 660 millimeter in width, and 150 millimeter in height dimensions. Then we can see in figure 5 the dimension design of a final schematic of the project, and the figure 6 shows the PCB layout of the hardware setup. Then we have the fourth step as a robotic vehicle development. After all the hardware development is done, now there is a requirement of a development of a robotic vehicle which consists of all the essential parts. The robotic vehicle mainly consists of a robotic arm and a dustbin on mounted on the top of the robotic vehicle. Then we have the computer vision system development. The above figure 8 shows the example of ground segmentation where the object is detected in the camera which sends the image as an input to the CPU. Then the CPU recognizes the type of the garbage whose database is already present in the memory of the CPU, which helps the CPU to recognize the garbage in the real world. The next figure shows the example of recognition of the garbage type. Our developed computer vision system recognizes the and label the yellow box to that object and also a red dot in the area of interest. Here the area of interest is a green color line. Then we have the neural network model interface. In figure 10a shows the training deep neural network where it consists of input layer and output layer, where the in between it consists of hidden layers, and the figure 10b shows the input neurons. We have used a convolution neural network to train our model in our project. Then we have a robotic arm development where it consists of two servo motors. The front end gripper can grasp object within the weight of 1 kg located within the diameter of 10 centimeter. Then we have eighth one, that is the algorithm for different types of garbages, which consist of several layers starting from layer 0 to layer 8. As a result, we have a softmax course with 4 different classes. Then the programming. For the testing purpose, we have done the programming in PyCharm software on Windows operating system, and for the training purpose, we have done the programming in Thorny IDE tool in Linux operating system. There are codes for image processing, image detection, movement of various motors, and so on. And these all codes are combined together to have one code, which is called as mother code or mother program. Then we have a model building. The figure 17 shows the block diagram of our model where all the input and output components are directly or indirectly connected to the Raspberry Pi as shown in the block diagram. Then we have assembly. After all the steps of methodology, all the components and devices are assembled in the base of the robotic vehicle as shown in figure. Then we have testing. For the first set of training data, 100 sets of images were taken for a category like bottle, box, paper cup, and ink bottle. The images were used both to train our model as well as to test. Both the train and test images were converted to XML and CSV with the bounding boxes. The bounding boxes were drawn across each image to explore the region of interest. And then we have the concept of loss function in testing. Initially we have 11 point loss, and while testing 60-second step we have a 3-point loss, and at last at the 437th step we have a loss of 1.22 point. Then last is the optimization in methodology. After all the steps in methodology, the project is ready to optimization, and now the smart garbage boot gboot is ready to use, which is completely autonomous in its nature, which means it doesn't require any kind of human intervention for its operations. The further slides will be explained by my friend Akshay.
Thank you, Navin. Let us see the navigation. Whenever the robot will be turn on, it starts a position by means of the robot will be ready to work and will start a move forward. While moving a forward itself, the robot will be working on the ground segmentation and will also work on the garbage detection task. If any of the object on the ground it is detected, then the robot will be starts tracking that object and will check the object nature. If the object on the ground is garbage, then the robot will be object tracking. If not, the robot will be avoid the object as a obstacle and the starts a move forward. When the detected object will be garbage type, then the robot again will go ground segmentation to recognize the garbage type. When the object approximately located at the bottom center of the image, the object will be determined as a garbage or common abstractal by the garbage recognition. If the object is regarded as a garbage, the robot arm pick up the garbage. During this process, if any whether RFID card comes into its contact, then the robot will be under the condition that will whether RFID cards it having a change in the direction command. If S will be change its direction, or else if its final RFID cards, the robot will stop its working. Let us see the hardware and software parts. Hardware parts: RAS Verify camera module, HDMI display for a RAS Verify, A4988 driver, stepper motor, DC geared motor, L298 driver, buzzer, servo motor, 16C servo driver, power supply, RFID sensor. Next, software user. PyCharm. It is the most popular IDE used in a PyCharm. IDE means Integrated Development Environment. The IDE is the software used to write a program using a tools like a editor and compiler. Second one, Toonie IDE. The Toonie is the IDE for a Python that is designed for a beginners. Third one, Shell Terminal. It is the computer programming that emulates a video terminal within some other display architecture through the typically synonymous with the shell or text terminal. Final, Linux. Linux is a family of the open source unique like a operating system based on the Linux. It is used to leading a operating system. Let us see the experimental result and discussion. First one, recognition accuracy. The key to pick up the garbage is the garbage recognition. If the garbage model fails to recognize or non-garbage object as a garbage, the robot will work improperly. Thus, the recognition accuracy was tested, shown in table 1. In order, the test of the ability to discriminate between the garbages and the non-garbages, shown in table 2. Second, computational cost. The average computational timing for a key algorithm is calculated and the results are shown in a table 3. The next slide will be continued by the Naveen.
Thank you, Akshay. Let's see the social relevance. The main purpose to develop the project is to take an initiative part in a Swachh Bharat Abhiyan, which can be helpful to clean up our public spots like bus stops, railway station, airport, hospitals, and a stadium, etc. The project is helpful to play an impactable role in a smart cities to keep them clean and fresh. Let's see the properties of our end outcomes are: since Smart Gbot is completely automated trained model, it won't require any kind of human interventions in its operations. The robot can work for a number of hours without taking any rest. Accuracy of outcome system will be expected high since it is AI and ML trained model. The robot will be expected to be finally efficient to perform its operations. The system can automatically detect and classify the little garbage. Let's see the conclusion. The smart Gbot can survive as a powerful tool for the cleaning of the garbage in a larger area. Let's see the future scope. To implement the secondary smart bin system with the help of IoT. To use a NVIDIA card instead of a Raspberry Pi to increase the data processing rate. To implement the global navigation system to improvise the current navigation with a GPS tracker. To implement a smart and a strong arm. Let's see the comments on a commercialization of the project and targeted users. The huge public and private sector people will be benefited. The India is still struggling to find out the efficient way for the waste management and cleaning awareness as it is following old tradition approach in the cleaning sectors, but we have a positive hope in our project which will be more effective and efficient to bring the positive atmosphere in cleaning sector. Our project will play an impactable role in the tourism sector of India. With the help of a smart G-boat, we can prevent the porokarmikas burdens like a skin disease and health issues. People with the health sector will be positively affected. The improved productivity of individuals attracted foreign direct investment, that is FDI. These are some reference we have taken for our projects. This is our 3 members. Thank you.
Hello everyone, my name is Naveen Nagendra Pachangi, and today me and my team are going to explain you the construction and prototype of our project model. So our project title is the Smart G-Bot, which is a smart garbage collection robotic vehicle, which is a Swachh Bharat initiative. The garbage. We know the garbage being littered in public places have a heavy scale in India, and currently there is no effective system for segregation of this kind of waste in India. So we have come up with an unique and with an advancement and machine learning and artificial intelligence, we have prepared such a robot which can be able to segregate the garbage at the starting stage itself. So this is the prototype of our model. Here you can see. So let me explain the construction and working of this prototype one by one.
Now, here we have a base of our prototype. Base of our prototype consists of all the essential parts and devices in it. Let me explain all the essential parts one by one. At first, we have a camera module. The camera module is an input device in our prototype which captures the image and acquires the image, and it will send the image to the Raspberry Pi. Then we have a HDMI display. HDMI display will mainly helpful for us to understand the machine learning and computer vision in our project. Then we have a RFID sensor and RFID card. Whenever a RFID card will come in contact with the RFID sensor, then our smart G-bot will change its direction by 90 degrees. After that, we have a power bank. The power bank is a power supply to the Raspberry Pi and camera module. It will supply the power to the Raspberry Pi and camera. Then we have a 12 volt power supply, which is a main power supply in our project, which will provide the power to all the motors and its controllers by the help of XL4015 power supply module that we can see here in this video. Then we have a speaker here. The speaker we have used for the purpose of spreading the awareness of Swachh Bharat Abhiyan. Whenever our G-bot starts, then it will play a Swachh Bharat anthem, and whenever the RFID card will come in contact, then also the speaker will play the Swachh Bharat anthem. And then we have a connecting board here. Connecting board will connect all the essential parts as per the schematic diagram and the circuit diagram. Then we have a Raspberry Pi module. Raspberry Pi module is mainly responsible for all the activities in our G-bot, which will work on image processing, image capturing, image detection, and also ground segmentation, such like tasks. After that, we have a trigger pulse, a trigger button. Whenever we press this button, the trigger cycle will start, and after that, from there only our entire project will start working. And here we have a switch for our project, main switch for our project. After that, we have a limiting switch. Limiting switch is an indicator which indicates the home position of our arm. And now we have a arm. Arm will be helpful to pick up the garbage that is littered on the ground, and it will pick the garbage by closing its gripper, and it will be leave the garbage at the respective dustbin compartment by opening its gripper. After that, we have a smart dustbin module. In our prototype, we have mainly trained 4 classes of garbages. The first one is a plastic water glass, the second one is the ink bottle, and the third one is any kind of a bottle, and the fourth one is a tea paper cup. So these are the 4 different classes of our garbage, and that's why we have made 4 compartments in the dustbin. Whenever a particular garbage located near the camera, then the Raspberry Pi will work on image classifier and the dustbin will change. Now let me brief out the motors that those are used in our project. The first motor is a stepper motor. We have used stepper motor for the purpose of horizontal movement of our arm, that is connected with the help of belt that we can see here. These stepper motors are connected to the A4988 driver, and this A4988 driver is directly connected to the main power supply and also the Raspberry Pi. which will take the commands from Raspberry Pi to work on. And then we have a servo motors. We have used 3 servo motors in our project. One is in ARM and the second one is in the gripper of our arm. And at last the third one we have used to the change in the compartment of our smart pin. So that's why we have used the third servo motor below the smart pin. And these 3 servo motors are connected to the PCA9865 servo driver, which is a 16-seat servo driver. And then this servo driver is connected to the main power supply and as well as the Raspberry Pi. The Raspberry Pi will send the commands through this PCA9865 servo driver. And at last we have one more motor, that is a DC geared motor. The DC geared motor is mainly responsible for the movement of our robotic vehicle. That's why we have used the 4 DC motors at the 4 respective wheels. These 4 DC geared motors are connected to the L298N motor driver. And the L298 motor driver acts an intermediate between the power supply, Raspberry Pi, and also the 4 DC motors. So this is all about the prototype construction of our project.
Now let us see workflow of our prototype. These are some images of our prototype. Whenever we start our Gbot as a symbol of awareness, it will play a anthem of Swachh Bharat that we are going to see in this video.
स्वच्छ भारत का इरादा इरादा कर लिया हमने देश से अपने ये वादा कर लिया हमने स्वच्छ भारत का इरादा कर लिया हमने देश से अपने ये वादा कर लिया हमने.
After the completion of anthem, our Gbot will start move in a forward direction. While moving, the camera mounted on the vehicle will start working on the ground segmentation and image capturing. Image captured, automatically the position of the bin will change and the arm will move horizontally and it will pick up the garbage smoothly by closing its gripper to hold the garbage and leave the garbage at the respective bin. By opening its gripper, let us see one more example of a different class of a garbage. We can see a plastic cup which is littered on the ground and the camera will capture the image of a plastic cup and image will be processed. It will be recognized as a garbage by our trained machine learning model and it will pick up the garbage smoothly, closing its gripper to hold the garbage and leave the garbage at the respective bin by opening its gripper.
Now let us discuss the navigation of our smart Gbot. Whenever our Gbot moving forward, if any RFID card come in its contact with the RFID sensor, the our smart Gbot once again will play the anthem of Swachh Bharat.
स्वच्छ भारत का इरादा कर लिया हमने देश से अपने ये वादा कर लिया हमने स्वच्छ भारत का इरादा कर लिया हमने देश से अपने ये वादा कर लिया हमने.
Now the Gbot will change its direction by 90 degrees. The change in direction will take place by rotating 2 of the wheels in a forward direction and another 2 wheels will be reverse direction. For such kind of the rotation, the programming will be done thoroughly and saved in the memory of Raspberry Pi. After the completion of the rotation, again the Gbot will start moving a forward direction. During the navigation of our Gbot, the any of object on the ground is detected, the robot will start tracking that object and will check for object nature. the object on the ground is garbage, then the robot will go to the object tracking. If not, the robot will avoid the object as an obstacle and will start moving forward. When the detected object will be a garbage type, then the robot will go for ground segmentation to recognize the garbage type. The object approximately located in the bottom center of the image. The object will be determined as a garbage or common obstacle by the garbage recognition. The object is regarded as a garbage. The robot arm pick up the garbages. In this process, if anywhere the RFID card comes in its contact, then the robot will be under a condition. That is whether RFID cards it's having a change its direction command. If yes, it will be change its direction, or else if it is the final RFID card, then the robot will be stop its working. Let us see the navigation working of simulation type.
Now let us see the computer vision. It is referred as perception model. Computer vision is a scientific field that deals with how computer can high level understanding from digital image or video. It includes ground segmentation, garbage recognition and localization. The ground segmentation is used to detect object and ground. The garbage recognition determines whether the detected object is garbage or not. If the object is garbage, localization will provide the coordinates of the garbage in the image. Once the object in the ground was detected, then the robot will be controlled to approach for recognizing it more clearly and picking it up appropriately by the proposed object tracker. The object tracking can be realized through following steps. Firstly, the yellow rectangular boundary coordinates of the object in the image can be obtained by the detected image. The pixel coordinates of the top left corner and pixel coordinates of the bottom right corner with the help of convolution neural network algorithms will be able to identify the object center coordinates. Secondly, it will compute the difference between the object and the bottom center of the image. The image in this frame shows a single object detected. The image in this frame shows the multiple objects detected in the camera which sends this image to CPU. CPU is nothing but Raspberry Pi. Raspberry Pi recognizes the type of garbage whose database is already present in the memory of the Raspberry Pi, which helps the Raspberry Pi to recognize the garbage in the real world. With the rise of deep learning, the convolution neural network improves the image comprehension by learning more discriminative and richer features. The proposed robot should be capable of recognizing the garbage and other obstacles. If there is an object on the ground, the object tracker will control the robot to approach the object. When multiple objects exist in the ground, in this case the object which is detected in the area of interest, that is nothing but exactly at the center of two green lines, that object will be selected to track and that image can be acquired, used for the object recognition. Then robotic arm will pick up it and then place it into respective bin.